And we'd like to welcome in, coming in from Connecticut, is team number 7407, Wired Boars. And they have a fantastic machine they're going to be showing off here today as we go into week 6. We can't wait to talk more about what their progress is so far. And we have Max and Bennett both here. We're going to detail a bit more about the road. We have some CAD to show as well, too, all here coming up on the Open Alliance show. Your destination for first content, updates, and gaming.
Welcome to the fun.
First Updates Now is supported by Stryker Careers. If you are a college student or recent graduate looking for an incredible internship, take a look at Stryker. Stryker provides a housing stipend, great pay, and an opportunity to work with state-of-the-art medical technology equipment. Discover why so many First alumni are coming to Stryker for their internship or career at careers.stryker.com. First Updates Now is supported by Kettering University. Over 1/3 of Kettering's current students are former robotics team members. Go pro at Kettering University and get a free t-shirt. Students in grades 8 through 12 and located in the continental U.S. scan the QR code and complete the form by the date on screen and receive more information about Kettering. So starting out on the spot here, you guys have put a lot in the last 6 weeks. We haven't talked to you. We have not had this team online before, so we're delighted to show them off for the first team here on the Open Alliance show. So talk to me a little bit about, we'll get into the robot in a second, but like give me a warp speed up to week 6 here. Like concept design, where are you at right now and what's brought you to this point so far?
Yeah, so we did all the same sort of planning design that every team does. We decided to prioritize our climber. We figured that was the best way for us to consistently get points and also consistently get points, ranking points, independent of whoever our teammates are. Beyond that, we decided to go with this dual intake system, running a swerve drive. We think that this will help our drivers be able to basically circle the field, getting as many balls as possible. We think that one of the biggest challenges this year will be just picking up the balls as opposed to shooting them. There aren't that many game pieces. And then lastly, we want to prioritize the high goal and shooting into that really consistently. After that, it was just kind of get to work, CAD it, build it, and we're here now.
So let me ask you from the dual intake, I want to dive a little bit more into that first. So when you're looking at that from a concept perspective, I always think about what the driver thinks for something like that. So do you guys pick out your driver ahead of time, or is that something you determine like during the middle of the build season sort of thing?
That was a middle of the build season decision.
So are one of you two the drivers, just out of curiosity?
No.
Okay.
No, yeah.
So like, have you talked to your driver in regards to like, is that something you think that they're truly going to use on the field? Like, do they find that convenient, or have they tried to bias more towards one side versus the other?
We haven't really done too much driving with the intakes yet.
Sure.
We've been driving a separate swerve drive that we built in the off season and practicing with that primarily. But this was one of the things that the drivers did say that they really liked. Our concept for the dual intake is it's fully dependent on how the field is designed. We see the 4 different ways out the ball leaves the hub. And because of that, we think the ball, 90% of the time, 80-90% of the time will be to the side of us.
Sure.
And really not the front or the back. And so our idea with the dual intake is to essentially do loops around the hub the entire match. And if it's to the left of us, start going left. If it's to the right of us, start doing that loop right. And we think that that's feasible because of our swerve drive.
Do you think like the cargos actually, like, are you looking at having it come in kind of from the side with the swerve drive, or do you still look at like taking that from a front end approach, so to speak?
Yeah. I think the idea that the way we envision the game to play out is that we'll basically have a robot circle around the hub in like a larger radius.
Yeah.
And
with the shooter pointed at the hub.
Yeah, and keep the shooter pointed at the hub, and that way, as we like circle around, as the balls come out, we'll be able to like intake.
It's like a search and destroy mission going on or something like that. So I guess
yeah.
For sure. Well, let's you talked a little about your intake. Is there anything else from a designer or from a mechanical perspective, or anything else that you want to talk about on your intake?
I can do that. Yeah. So it's pretty simple. We have vectored intake with mecanum wheels to basically.
Jackson, do you mind bringing the camera around to show it real quick?
Sure. So, as you can see here, we have mecanum intake with vectors wheels. We have actually the intake point of like the balls going into the robot kind of off center, and that's because like we had to keep the entire like tower system. Wait, can you point the camera over here? We had to like offset the entire tower system because we needed to keep the center of mass of our robot in a very specific place so that our like hanger system would work.
Sure.
And we'll talk about that later. And that's why we decided on mecanum wheels and vector intake. And as you can see, we have like this spinny thing that like kind of like just has Velcro straps on it and catches any balls that might be like bouncing or anything. And
yeah, we found that with the bouncing balls, first, second bounce, we're never going to catch it. But kind of third, fourth, and it trickles for a while at the end of its bounce. And any sort of trickling, we think that the Velcro straps are really good at kind of slapping it down and stopping that bounce so that we'll be able to intake it.
So it's kind of like a flail almost, right? Like it, where, like you said, just kind of we'll just slap it down and bring it right into your intake sort of thing.
Yes, exactly.
Yeah, that's the idea.
And you said those are Velcro straps. So it has from a Velcro material. Do you find like that actually does make a difference in regards to like the interaction with the cargo, or have you tried different materials on the front there?
Yeah, so we tried zip ties and a whole bunch of different materials. We liked the Velcro because we found like with zip ties and a couple other things, it would tend to just kind of slap it away instead of slapping it down.
Sure.
Sorry, I just realized the camera wasn't over there. So it would, especially with the zip ties, that was kind of the main thing we were considering. And it really just like, instead of grabbing it and bringing it down, it would kind of slap it. And while it worked, it just didn't work as well.
Well, let's kind of keep moving on into your robot. If you figure that ball path that we followed it, right? The cargo into it. So as we go into like your indexer, talk to me a little bit more what goes into that as well.
Yeah, sure. So as you can see, we intake the ball. It goes up based on these two Omni wheels into the robot. We have this entire tower system to basically eventually lead to the shooter, which we have not yet fabricated, but it'll be coming soon.
Yeah.
And I guess this entire superstructure, there's not really much.
Yeah,
to say
it's not
about
all that
it.
complicated. It's what a lot of teams will run, but
Pretty simple.
Is there anything from like a sensors or perspective or any sort of programming perspective you're looking at, like using like beam breaks or anything like that?
yes, actually. So we don't have it in right now, but
Yeah.
I think the code team's actually working on the sensor right as we speak. But we're gonna have a sensor in here, and it's gonna sense when a ball, comes by, stop, and that will be the maximum we intake the ball. And then we'll only run the intake from that point. So we won't be running, we won't be shooting the ball. We properly intake too.
Yeah. So basically sensors is a must on this robot because for 2020 Infinite Recharge, we had basically a system where the driver had to keep everything in mind when he was controlling the index and the shooter. So he had to spin up the flywheel and then manually keep in mind the position of the ball in the index and then move the index to the shoot. And that basically led the driver to be kind of stressed out during competition.
Yeah.
And it just wasn't really that great of a system anyways. So we're definitely going to automate shooter feeding this year.
Well, I think let's skip over the shooter for now because we'll bring up your CAD in just a little bit because I'd be remiss if we didn't talk about the climber that you have. I know your team's really proud about what you're looking doing for a climb on there. So tell us more about it and any successes you might have had or anything that you might have learned so far with your climbing system.
Yeah, so day one, day two, this was our biggest thing. Or basically our entire robot, our center of gravity, all of that has been designed around allowing this climber to work. We're doing what a lot of teams have been doing. I think a lot of the First Alliance teams have shown something similar.
Yeah.
But this, we go up and grab the bar, move us over. These basically.
Yeah. So we grab the bars, and then after we grab the bars, and then as we pull ourselves up, basically what happens is this hook drops below this one, and then this hook will hit the bars and slide out of the way and catch on again, and then that allows our robot to basically the weight of the robot is on these hooks, and then we fly these out, tilt our robot, and then lift our hanger again, catch on to the next bar, which is like offset, and then we just like repeat the process, like monkey bar our ways up.
Have you done any testing on this so far?
We've not. We just got the code team to get it actually run up and down. We haven't gone on to the bar yet.
Yeah, but we have done quite a lot of like motion studies and stuff.
Yeah,
CAD, and we're like pretty sure.
We're expecting to test probably today or tomorrow.
So from an optimal standpoint, like what are you looking at from like a time frame? Like how long do you think it's going to take you to climb? And are you starting on the mid rung? I'm sorry if I missed that.
Yes.
We are.
Okay, so going from mid rung to traversal, what's kind of your objective for the amount of time you want to take to get up there?
We're hoping in the ballpark of 20 seconds.
Sure.
We've seen a lot of teams do it, and it's been taking them quite a bit of time, but it's also early testing. So we've seen teams do it, I think, 38, 40 seconds. We're hoping that with adequate amount of time to code and that sort of thing, we have a great code team. So, yeah, we think 20 seconds is a realistic goal. We'll see how fast we can get it, though.
Well, and the 20 seconds as well too, right? Like if you look at from a time value perspective, right, of like how quickly you could shoot in versus that 20 seconds sounds, I think, pretty good in that realm of like, hey, it's going to be fully worth it that we do a traversal at that rate as well too, right?
Yeah, and keeping our time low also ensures that as we get on the mid run and get off the mid run onto like the traversal and onward, our teammates will have the opportunity to also get on the mid run.
Yeah.
So,
talk to me from a climb wise. What is the material of like the hooks that you're using? Is that just aluminum on those, and then is that painted or powder coated? What are you doing for that?
Yeah,
they're just quarter-inch aluminum plates that we CNC'd out, and then powder coated gold, which are school colors.
Oh, cool. How did you come up with like the shape that you want to use for that? In particular, with the ones that are out on the pneumatic pistons.
For these,
you remember how that was designed?
I think we drew inspiration from a lot of teams for, I don't know which year it was where they had to climb up the pyramid.
Sure. 2013. Yep.
Yeah, 2013. And then we looked at the hook designs for those and kind of figured out like why they made the geometry that way, and like adapted it for this year.
And the one thing with this big back plate is when we're going up the bar, if the bar, it's kind of excessive, but if the bar were to hit back here, it could still hit and bring down this piece and slide in.
Sure. Other than, before we hop into your CAD, is there anything else on this robot you want to talk about or highlight that we can see right now?
I mean, not really. I mean, one thing I think is really cool is our school's logo is a CNC onto our polycard, which.
Yeah, that looks awesome.
Yeah,
when's the backlighting getting put in for that?
Well, we'll see.
We've talked about doing that. We'll figure it out.
Yeah, shout out to Sebastian who did that. He's one of our designers.
Nice. So let's hop into your CAD that you have up here. We'll go a bit more into some of your design that you went, of course, into it. I'd love to hear more about any testing you were able to do or anything that might have like changed some of your initial direction when you started creating this in Onshape.
Yeah, for sure. So one of the reasons that we don't actually have our shooter built on our physical robot right now is because we put a lot of time into prototyping our shooter. And actually, initially, we were going to do a single flywheel shooter, but through testing, we basically found that it wasn't as reliable as the dual flywheel, and that's why we made the decision to switch to double flywheel, and you can see the reflection of that in our CAD. And then, so basically, what you can see here is just an adjustable dual flywheel. This, if you can see my mouse, this gear pinion turns this gear rack, and that allows us this component to go upwards, which I can't really drag it up right now because Onshape isn't too reliable. But this will basically allow us to change our angle of attack for shooting. And
the code team wanted to have a couple of positions. So we're thinking, I think it was a 60, 70, like 80 degree angle. So that will allow us to go between those three positions. And then for anything in between that, we're planning on changing the velocity of the.
So where does that
the
actually,
flywheels.
like, if we
Yeah.
translate that into the field, where does that mean you're actually planning on shooting from?
We're hoping to be able to shoot from pretty much anywhere relatively close to the hub. Just using a limelight, get distance and all that sort of thing. We basically want to test to see how far back we can shoot. We've seen a lot of teams have been having trouble with bounce outs, especially from further distances. So certainly we want to be able to shoot from against the hub, from the edge of the tarmac, and then maybe a foot or two back from the tarmac. But we want to see how far we can push that, and that will just go down.
And what's actually determining, like, when you look at the distance? I know you said you have 3 different positions and then some programming. Like, what kind of sensor is actually determining, like, hey, this is the position it should be in, and this is the RPM it should be shooting at?
Yeah, so I'm actually not too familiar with this, but according to Ethan, who's on our coding team, you can basically tell the position that the distance that the hub is away from our robot based off the angle of the limelight. I'm assuming that's right.
Okay, so you're getting feedback from the limelight, essentially.
Yeah, we're using the limelight for a lot of things, and based off that position and based off like, I mean, we've run a lot of simulations, just the physics of how the ball will fly through the air, but obviously there's a lot more factors in real life, and that those simulations might not be accurate.
Sure.
So we're expecting to just basically just bring our robot and test a bunch of different distances and see which angles and which speeds work, and we'll assign each of those like to like a certain distance away from the hub, and that's probably how we'll carry out.
Yeah, we've got kind of a preliminary sample that we use Desmos for, but we haven't, it's not going to be real to actual physics, so we'll have to test that.
As we start to wrap up here a little bit, a couple things I just want to ask you on your shooter, since we haven't covered too much on that yet, is looking at your wheels. They look like, from this angle, you look like you might be using like Fairline wheels sort of thing. Is that the wheel choice you're going with? And have you done any testing in like how your wheel choices are gripping to the cargo or anything like that?
Yeah, so for we use basically these wheels for the 2020 game, and
Can we show them on the CAD? Yeah.
like these.
Oh, sorry. Yeah. My bad.
Yeah, no, it's these. For the 2020 game, and I think we found that it's going to either be these or I don't remember what
we were
the
trying with
name
some
is.
stealth wheels, but I think we've decided on using these.
Yeah, we found that these work pretty well, and we can always switch them out after. So we're not really too caught up on that.
Are the wheels that are kind of like the upper ones, are those powered as well too?
Yeah,
Like
yeah.
you have a belt driving all of them, right? Yeah.
Yeah, the belts aren't in the CAD right now, but all the distances are mapped out, and yeah, they're gonna be powered as well.
Well, is there anything else from a CAD perspective that you want to go over? Maybe we weren't able to see on the robot or anything like that at all?
Not too much really. We haven't implemented pneumatics on our actual robot yet, but they're here in CAD.
Sure.
There's actually not too much left that I think we've pretty much covered everything.
Yeah, I mean, I think you guys have made great progress, and obviously you play in a week 1 event, right? So that's going to be coming really quick, and I know you got a lot to get back to, so we'll let you get back to building and letting your programmers have some time with their robot. So once again, 7407 Wired Boars, really appreciate you showing off your robot. Thanks for coming on the Open Alliance show, and wish you best of luck going into your week 1 event. Thanks a lot for taking the time.
Yeah, thank you for having us.
Thank you so much.
Thanks to Kettering University for their support of this video. Over 1/3 of Kettering's current students are former robotics team members. Go pro at Kettering University and get a free t-shirt. Students in grades 8 through 12 and located in the continental US, scan the QR code and complete the form by the date on screen and receive more information about Kettering. Thanks to Stryker Careers for their support in this video. First alumni and mentors are making Stryker a top priority for their internships and careers. That's because Stryker knows that those in First are the leaders and innovators of tomorrow. If you want to help make the world a better place by creating life-saving medical devices and technology, get started at careers.stryker.com. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow and check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.